Hello, I hope you are doing great. If you really look at what were the previous lectures we have gone through, most of it was on HDFS. As we know, HDFS is the storage layer of our Hadoop ecosystem. We also have known that MapReduce is also one of the component of Hadoop ecosystem. Can you just check diagram what you had drawn about the Hadoop ecosystem, where exactly MapReduce sits? As a part of this lecture, we'll try to understand what is MapReduce at a very, very high level. Let's get started. Any idea what is MapReduce? Do you guys remember anything about the MapReduce what we have discussed earlier at a very, very high level? Just pause a video and try to remember what is MapReduce. Before we really get into MapReduce, do you guys remember the story we discussed in one of the previous lectures? Is there any bell ringing? Yes. We discussed about preparing a biryani or pasta, right? You had a wonderful party with your cousins, and one of your friends calls you on Sunday morning, and he or she wants to come to your place. You guys want to cook a biryani or pasta for them. I hope you guys remember. It's a wonderful story. So then you are a very good convincing person. You end up convincing your friends or cousins to slice uh, three different types of vegetables. And then all of them obediently slice the vegetables you have given. And before you prepare a biryani or pasta, you fry them one by one, like onion, capsicum, and then tomato. So in order to fry them one by one, since all of your cousins or friends have sliced them in isolation, you have to combine them now. So this is what is MapReduce. MapReduce is a programming model. It's a software framework for distributed processing. We have a HDFS for storage. If you remember, HDFS is storing the data in a distributed manner. Now that there is a component to take care of the data to be stored in a distributed manner, a component or a programming model called MapReduce takes care of distributed processing of the data which is already distributed across the different nodes in a cluster. It requires running the processes on many machines. Whenever you have a data distributed across different systems in a cluster, you have to go and process the data in different systems. There is an inherent parallelism because the data is distributed. So MapReduce takes the advantage of inherent parallelism in data processing. Why do we really need MapReduce? We need MapReduce because we already understood systems which are there in the modern days, from either maybe machines from aeronautics or social media or people or organizations are generating huge amount of data. So we need a programming model which takes care of distributed processing so that we can get more things done in less time. That is the reason we need MapReduce. As we understand, we are saying we are trying to process the huge amount of data. The scale is very big. We are not talking about 1 MB, 1 KB, or even 1 GB for that matter. We are talking about 100 GBs or TBs or ZBs, that is zettabytes. When we are talking the processing of this scale of distributed processing is taken care by two steps in MapReduce. The first step is map, the second step is reduce. So the big data which is stored in a different systems, we have a MapReduce taking care of the distributed processing of that data which is distributed, and we'll have the distributed processing happening in two important phases, that is map phase and reduce phase. So then we'll get the final output which is required by the user. If we really see, what do we really need to do here? I mean, as a developers, as an architect, as a programmer, what exactly we need to do for processing of that huge amount of data by using a MapReduce? We understood MapReduce is a programming model for distributed processing. In this MapReduce, map and reduce functions are defined by a programmer. That is you and me or whoever is trying to work on MapReduce. He or she takes care of defining these two functions, that is map and reduce. Rest of the things is taken care by Hadoop. What do I mean by that? We'll try to understand that in detail in the upcoming classes. At this point of time, what we need to understand is map and reduce steps in a map reduce is defined by a programmer. That means he or she is literally coding that in a Java code. And Hadoop framework is taking care of other steps. What are the other steps? It may be a shuffle, it may be a sort, it may be partition. We'll discuss those things in our upcoming classes. At this point of time, you just remember that the programmer defines the functions in a map and reduce. Rest of the steps taken care by the Hadoop framework behind the scenes. If you really drill down one level further, MapReduce, we already understood, it's an operation performed in parallel on the small portion of the data set. Why am I saying small portion of the data set when I am saying this is a huge data and all those things? The reason being the data, whichever is big, is not at one place. That is broken down into smaller chunks and distributed across the different systems. Map phase is acting on the small portion of the data which is split or broken into the small chunks and stored in a individual nodes or individual systems in a cluster. What they do is they work map phase or map step work on the small chunks of the data, and then they transform the input records into intermediate records in a key value format. How and what is key value format? We'll try to learn that in the upcoming classes. At the moment, maps are the individual task that transforms the input record. Assume this is the input record into intermediate records called key value output. Then what reduce step does is it takes the map output and acts on them, processes them, and produces the final output. If you remember our pasta or biryani story, you just think of this is the map phase where the parallel processing of the data is being done. These are the intermediate output. This is produced by map phase, and reducer takes, this is the output of the map phase, and reducer takes this is the input and combines the values of intermediate results from a map phase. That is what is happening in the map and reduce phase. Just to summarize, map is a step which can be performed in parallel on the small portions of the data which is distributed across the different data nodes. A reduce step is a step which takes the outputs from the map phase or map step and combines them to give a final output. I hope you guys understood this really well. Thank you.